Hello, welcome back friends to DCT Lab, and for obvious reasons I am Mr. DCT. Okay, so I'm going to be building hash tables from scratch in C++. So hash tables are one of the most powerful data structures in computer science, and they are supposed to run in a constant time complexity of O of 1, that is just direct accessing, right? But what if I told you that under certain conditions a hash table can completely break and become O of n? Yeah. And in this video I'm not just going to explain hash tables, I'm going to build one from scratch, break it, fix it, and then turn it into something close to what real systems use. Okay, so without any further ado, I'm just going to dive in. So let's first of all create our folder that we are going to be using. So I'm going to name it hash. Let me say hash form. Hash form is a cool name, right? Let's see this at hash form. Okay, so then I'll create a folder the same name, hash form. It's going to be a C++ file. C++. Okay, clear my screen. Okay, that's a file there. So on my right hand side here, this other terminal, we're going to use it for compiling and running our program, while here we're going to be coding. I'm going to be using NeoVim, and for disclaimer, just to let you guys know, I'm from a C background. I just got introduced into C++ by my lecturer, so I just want to also use C++ as to level up my skills. So maybe I may be making some kind of syntax. I'm from a C background, but I think it will be more quicker to adapt with C++, so just bear in mind. Okay, I'll be using NeoVim editor for our coding, so I'm just going to say NeoVim hash, what's the name, hash function, right? Oh my god. Okay, without any further ado, let's just dive in. So the first thing we're going to do is, as usual, include the libraries we are going to be using. So yes, hash include stream, right? So this is for our input output, right? That is the C in, C out. You can name it so you know C++, you know what I'm talking about. Okay, next is going to be vectors. We are going to be using vector for our dynamic array. Yes, since we are going to be dealing with, in order to arrange collisions in our hash table. In fact, you will understand later on as we are going to continue moving along. Okay, next is going to be I hope it's supposed to be like this, hash include, sorry for typo. We're going to use function, another distinct library. This one is going to be responsible for there's this inbuilt function called hash, so it's going to be like more of a professional way to use our hash engine. Yeah, so another one is going to be, we're going to use string. Yes, string is required for our values that we're going to use in our table. Okay, next is going to be just we're going to use this algorithm. Okay, now again, as usual, namespace, using namespace that std, right? How do you spell it? std. Okay, though it's not really advisable to use namespace because it can create like kind of some conflicts with the C++ library. Anyway, it's another topic, but it's advisable to often use like declare what you like. Let me say std, then you give the what you want to use, like let me say string. Anyway, it's not the topic for today, but yes, something like that. But again, this will make us code faster. It's not really advisable in professional way. Okay, after namespace, continuing. Now we are going to create our node structure, right? So in our node structure, we are going to use a template. So we create a template which is going to take as parameter the key, the value, and this will allow the user to use any data type. That means either an integer, string, etc. So you can just create it anyway without just stop explaining. So I can say type name. Okay, now this is going to be key. Okay, it's going to be a key, then type name. Again, I'm doing this, then v for value. And do this so that this template can take any data type. It could be a string, integer, or whatever. So struct. Someone like me come from C background. This is again just similar to C. I can already see a difference here. We have already started using though yes, something like vectors is from C++. Yeah. So K is going to be the key. V is going to be the value that the user could enter. I don't know. Do you guys really know what we are doing here? Like what hash tables are or whatsoever? Anyway, let's just pause here and talk about a bit about hash tables. Well, at a high level, right, a hash table is a data structure that stores key values pairs, and the goal is simple. Given a key, we want to find its value instantly. So to achieve that, we will use something called hash functions. A hash function takes a key and converts it into an index in an array. So instead of searching through data, we jump directly to where it should be, right? So yeah, that's basically it. So let's just look how to implement this. Okay, continuing. That was we need to create a pointer, that is a chaining pointer. I don't know, I think you have somebody for you to really understand what I'm going to be doing here. You need to really revise a bit about hash functions or hash tables. So I'm going to create a pointer for chaining, because I'm going to be using close addressing, right? That means if there's a collision, that means if someone inserting a value or an item that already exists in a particular index, instead of it creating an error, it should just chain it. That means create a linked list. So this node is going to be pointing to the next like we created a next bucket in the list, right? So it's called close addressing, right? So yes, I hope it's well understood. Okay, after that, now I'm going to create a constructor to quickly like create a new node, right? So node, so I'm going to create k, which is our key, comma k going to be k. This is our constructor, right? This one is going to be like this. So again, our console, like kind of anytime we call it, when our main program is going to run, it's going to quickly run and create a new node. So k, then v. Okay, so that's basically it. And I'm going to say key. This console will just going to automatically run and do all of this. Value is going to be v, like this. Okay, comma next node. So we'll create a new node in time, just immediately as we run our program. Okay, so next, if is the last, going to be node point, the last one is going to be point to a node pointer, right? Well, I think this one is a C++ functionality or feature, because I don't think null ptr is in C. I think it's just null in caps. Yes, I think so. So that's okay. I think that's it, right? Yeah, yes. Okay, then put a semicolon. Okay, that being the case, we are going to continue now. We enter the hash table. Like, we need to create a method and a template for our hash, like let me see the hash table class. Yes. Okay, I think I should comment it, or should I not? Let me see a hash table class. Okay. Okay, so we're going to create another template. Type name. We're going to be gay, comma. We're going to have type name again for the value, right? Okay. Now our class is going to be called hash table. Like this. Okay. It's like this video is going to be long. Okay. Okay, private. It's going to be private as another feature in object-oriented programming in C++. In C, we don't have this. Sorry, again, I keep on referencing it because I'm from a C background. Okay, now I'm going to create a vector. Going to be private, and the vector is like a dynamic array where each slot is a pointer to the head of the linked list, right? So it's a vector note, right? Okay, which is that our key, v our value, right? Then let's close this. Buckets are simply like just the rooms in the array, right? This is how they spell bucket, right? If I'm not mistaken. Okay, size bucket count. We're going to create a variable that means they're going to like store the current capacity of the array. So I'm going to name it as bucket count. Again, I'm using the camel case naming of variables. I hope you know about different type of, yes, I'm using the camel case. That means I start the name of a variable with a lowercase, then the next word start with an uppercase. In fact, I don't know why I'm explaining all this, but anyway. Next, I'm going to create another variable. It's going to be the current name or number of items stored. So again, going to be size. I'm going to name it as element count. Element count. Again, I'm using the camel case method of naming variables. Is that how to spell it? Yes. Okay. Element count. Now the next is going to be the threshold to trigger the resize. Again, I'm going to explain this later on. It's going to be a float, and I'm going to name it as max load function, load factor. Okay, so this is going to be like how can I say, imagine like you are putting, like, storing elements in the hash table, right, and they keep on having a collision. That means of this appearing the same index is literally going to become like a linked list instead of a hash table. So it's going to be like this open address will just be creating the hashing elements, like I can say making like a linked list, right? And if you don't give a maximum length of it, is going to, like, you don't control this collision, it's going to be turned up, be like like I said, like a linked list. And if the number is too much, instead of it being of time complexity O of 1, is going to be O of n. So we need to let me say avoid that by giving a max load factor in the linked list or in the size of the linked list, right? I hope you get the point. Okay, so next we are going to create another method. This one is going to be, let me say, like to check if a number is prime. That means to proper distribute, because if you are to give a size of the array, is advisable in hash table for it to be a prime number, in order to improve our distribution, right? So when you say bool, it's going to be is prime. So going to be a bool, this is a boolean. Yes, so is prime. It's going to check. That means take the size. going to size n, size of the array. Now in that size, I'm going to check if, so if n is less than 2, right, I'm going to return false. Okay, now for, let me say size, size I, right, equals to, let me start from 2, right, and I times I is equals to less than or equals to n, right. I'm going to say I plus plus. Okay, now in this I'm going to say if n mod, we're going to check if it's prime. If n modulo modulo I, right, is equals to 0, that means it's prime, right. Then I'm going to return false. Okay, else I'm going to return true. Okay, so we're going to, in this case being done, we're going to create another method, right. So this one is going to be how can I put it, this one like is going to find the next prime number to the new node or to the new table size. So we're going to be size next prime, so like we'll find the next prime number to the new table size. So after, like, if you have, after our, in fact I'll explain it as we are moving along. So size, I'm going to name it as next prime, right. So size next prime is going to take parameters size, and going to be n. Okay, so y is not prime, right. We're going to check if our this thing is prime, from our above method is prime. We check whether it's prime. So I'm now going to check y is not prime. So I think it's, the function is like this now. So y if it's not prime, like this, if I'm not mistaken, that's how we use in C. So take n. If it's not prime, I'm going to do I'm going to put it here, yes, n plus plus. So basically we want to find the next prime number to be the new table size. So that's just basically it in summary. Okay, that this supposed to be like this. It's not going to have a compilation error. Okay, return now n. Okay, yes, that's it. Now we're going to need another method. Now this one is to like help us like convert any key into a valid index using the division method. Again, we are going to be using the division method, and that's where that we are going to make use of this our functional library, which contains that hash this thing. So it has this inbuilt I thought you are going to talk about it, right? It has this inbuilt std hash feature in C++ that is going to like help us do the hashing engine. So we're going to be using the division method, right? Okay, so we are going to like I said, convert any key into a valid index using the division method. So I'm going to say size to name as get index. Again, I'm using the camel case method of like naming variables. Const is going to be k is going to store the address, which is the key, right? So the address of this key, right? Okay, after that, now we're going to say use another std hash that from this library that I talk about, and this will be like, it's like I said, it's a built-in C++ tool that turns any object into a size number, like into a number, right? So let me just apply it, you see. Okay, so size, I'm going to say I'm going to name a hash how should I name it? I think hash value is okay. Again, let me just use again input hash ss here. Okay, so hash value is going to be equals to, now let's make use of that std hash, right? Again, it's come from that library functional, so if you don't put it, you cannot use it. Okay, key and I'm going to say key. Okay, like that, and with a semicolon. Okay, so yes, it's correct. With that, we are going to return our hash value, then use the division method now. So the hash value is going to be modulo the bucket count. Okay, like this. All right, so our next method, we are going to like let me first of all, okay, and here we semicolon. Okay, let's continue. So our next method is going to be our load factor. Remember I told you about the maximum size line, so we need something that will calculate the current crowdedness, right, of the table. That means as we are filling the table, there's something like counting, or let me say keeping record of how the percentage full of the current list, right? So we're going to be float. I'm going to call it load capacity. Let me say just load factor. Load factor like this. I hope my spelling is correct. Okay, in load factor we're going to return to be float element count divided by just normal division divided by bucket count, like this. Okay, with that being done, our next thing is going to be I will create another method. This is, how can I say, this one is going to be like the core of our hash table. So this method is going to like expand the table when it gets too full. I don't know where I get the point. Like how can I put it? If we fill, let me say the size of our table is let me say 3, and we reach 3 elements, right? You need to expand it, maybe limited to 5. I don't know where I get the point. So to map keys to indices, right, we are going to be using like this built-in C++ hash function, like I said. So basically that hash distance is like the core of our program. In fact, let me just go into it, you see how it works. Okay, so like I said, I want to calculate a new size, double it, then find the next prime. Okay, so the core of our logic is going to be this function called void. Going to be rehash. Okay, I hope I spelled it correctly. Rehash. Okay, so void rehash. So like I said, the core function logic, which is going to expand the table when it gets too full, right? So it's going to be like generating itself. So the first thing, I want to calculate the new size. That means we'll calculate the new size, double it, and find the next prime. Again, it's necessary to use prime numbers for size so that we'll improve our distribution in the list. Okay, so I'm going to say size new bucket. Again, I'm using the camel case. In fact, I'll just stop saying it. New bucket count. New bucket count is going to be equals to next prime, then bucket count times 2. So like I said, we're going to double it, then find the next prime. So times 2 and next I want to like tell the user when the rehashing is triggered. That means when you have, let me say, you have reached the maximum space of your hash table size. When it's regenerated, we need to tell the user in the terminal. So again, we're going to use cout, which stands for character out, and it's from that our library iostream. I don't know, there are some kind of details that I'm really explaining, maybe because I'm new to C++, but an expert would tell me that why keep on explaining all of these things. Just go straight to the point. Okay, so let me just go straight to the point. Cout, we are going to say something like rehashing triggered. So /n for next line. I can say rehashing triggered. Is it how to spell triggered? Okay, exclamation sign. Rehashing triggered. So expanding a table, I can say expand table to buckets. Yes, so that we tell that like we expand table, the new bucket count, then now the like we're going to like expanding rehashing trigger, expanding table to I give the number or the new bucket counts, then buckets. Get the point? So I'm going to say expanding table to going to be our new bucket count, then buckets, just buckets like this. Okay, then /n for next line. Okay, then I add my semicolon. Always do that. In fact, from C background, I know that we always use it. Okay, next we are going to like now create a temporary new table, right, with a larger size. So again, this should be, I think I should even kind of like comment something here, because this is really the core logic. So I can say I can put something like core logic. Yes, rehashing, because the table is going to be expanding as the size is increasing. So okay, here we need to create a temporary new table with a larger size, right? Again, we're going to use our vector. So vector is just our dynamic array. So vector node K for key, V for value. Then we're going to like to the new bucket, right? Like, remember I said we're going to create a new table with the larger size. So vector node key the value, then going to be to this new buckets, just new buckets. Okay, the new bucket count, comma, no pointer if it's the last element. Okay, remember to end with a semicolon. Okay, so that's it. The next we are going to now iterate through. So move through every node from the old table to the new one. I don't know where I get the point. So I'm going to use a for loop. So for typo. So for auto head buckets, right? So move through it, then we're going to say note the value and the key, the value, then move through the name it current equals to head. So we're going to take the current and move through it, take the current head and store it, then what is in the old head and store it in the current variable. So say head. Okay, I hope the syntax is well formatted. Okay, while current, so let's check. Why this current going to be, what should I put, note. So we'll say note the key, comma, the value, then now to next going to put as next note. Okay, it's going to be equal to, now next one is going to be equals to the current let's say just next. Yes, so the current is next note is going to be current, which is pointing to next, right? So you really need to do some about some pointers before you can really understand well what I'm doing here. Okay, after that now, so basically if I'm to summarize this line here, right, is save the rest of the old chain. I don't know where I get the point. Okay, let's just continue. Okay, now I want to, how can I even put it, I want to recalculate the index because bucket count has changed, right? So to do that I want to say size. If bucket count has changed, I can say size new index equals to sorry, is going to be std hash a function and we key, then this so we're going to be current, which is from key, yes, modulo new bucket count. Okay, so again here we are recalculating the index because the bucket count has changed. That's basically why we're doing that. That's eventually that line being explained. Okay, now we want to insert the note at the head of the new chain, right? That's going to be the fastest way. So to insert the node at the head of the chain, right? I'm going to say I'm going to put current, which is next, pointing at next, and go to new buckets. So new buckets. This one is a new index. Okay. And that's semicolon. Now our new buckets now. Our new buckets in new index, right, is going to be equals to correct. Okay, now let's move to the next node in the old list, right? So I'm going to say current equals to new node. Yes. Okay. That being done, next I think now we need to like swap the, let me see. Okay, I need to swap the old table with the new larger one, right? Remember our new table size have changed, right? So we need to swap the old table with the new larger one, and this is going to be just a few lines. So I'm going to say buckets. So buckets is going to be equals to new. I'm going to move it. Move new buckets. Right. Okay, like this. Alright, then now bucket count is going to be equals to new bucket count. Like this. Okay, so that's basically it. We'll swap the old table with the new larger one. Okay, I think that's all. Let's make sure our looping is correct. So this loop is for rehashing, right? So the first loop holds the rehashing, and this other loop, yes, let's make sure everything is intact, because if the looping is not correct, then we might end up having some command relation error at the end. Okay, so next we are going to create an public methods, right, or public classes. Then the first one is, okay, let's just say public. So our first public class is going to be, let's see, our first public class is going to be like, I'm going to create a constructor that will initialize, let me say, the table with the prime size, right? So in order to do that, I'm going to create a method called hash table. That's like going to be a constructor that will automatically initialize the table with a prime size. So hash table is going to be, we're going to take size, we're going to call size like size, let me see, we're going to give it an odd number like 11. Okay, now element count from 0, from index 0, element count from index 0, max, our max load factor let me just put, let me see if it reaches 75% full, right? 75% is 0.75, right? 75 and 0.75 f. Okay, yes. Okay, so in now I'm going to say bucket count equals to, bucket count is going to be equals to next prime, which is going to take data of size, then semicolon. Okay, now they need to print something out, like to tell the user in the terminal that let me say initialize hash table with something like the bucket count, right? So again, I'm going to use the C out, which is to display, and I'm going to name it, I'm going to say initialize hash table, initialize hash table with, I can say something like with yes, buckets. That means the nearest prime, right? So I'm going to say bucket count. With bucket count, I'm going to say buckets. I'll put something like nearest prime. Something like this. Okay. Next line with /n. Okay, so that's basically for this. Now I'm going to need another method. This method is going to be let's put it. So this one is going to like to insert or update the logic, right? Let me see. If you want to insert an element, the method does it. If you want to update, that means if you enter an element or you delete an element, right, automatically deletes it, updates the list. Okay. Oh yeah. So I'm going to name this. We're going to be how can I put it? Yes, insert is okay, right? So void insert. So this is going to take parameter as constant k, which is going to be holding the value as ampersand. We're going to do the address of key, comma const is going to be holding v, which is the address of value. Okay, now this first, now inside it, what we're going to do, okay, size, the index, right? Size index is going to be equals to get index. Okay, right now our get index, right, that we did. Where is it? Why am I not seeing it? But our get index method, that will get the index in the list, right, or in the array. So get index, we're going to pass in the key, right? And now we're going to use our node key the key and the value, right? Now we pass it current. Current is going to now be equals to buckets, and we're going to pass in just index. Hope the syntax are correct. Okay, so after that, now we will now search like the chain, right, if the key exists, and then update its value. So while while current, right, yes, while current while current, we say if, so if current in the address, that is the current key is equal to key, right, what are going to do, we'll say the current key is equal to key, we'll say current value equals to current value. So that's going to be basically it. Value, right, value equals to value. Okay, so again, we are just searching through the chain, and if the key exists, we update it. That's basically it. Okay, now we need to print something like in the screen or in the terminal, like to tell the user that the key has been updated. So I can say cout something like, I'm gonna put it, let me say updated key, right, let's have the spell updated, right, updated key. Okay, something like that. Then now the key, we're going to pass the key here, key. C++ syntax is kind of really funny. So I'm saying updated key at index. Okay, now the index, I'm going to pass the index. In C++ is quite different. Yes. So I need to pass now the index here, right? Okay, like that. I think yes. Then I end my line. End line, something like this. So let me make sure my syntax is correct. So I'll say cout updated key. I'm going to be in quotes, right? Then I'll pass the value of the key in here, and I'll say now at index again. I pass again. Okay, so I hope that not like kind of syntax error. Okay, return. After that, we're going to return. Okay, now else, right, else that we're going to say current going to be equals to current next. Okay, so here we have searched the chain, and if the key exists, we update it. Now next if, okay, so what if now another way would be like the key doesn't exist, right, we create a new node and link it at the head. Yes, that would be basically to solve that. So in order to implement that, you should say node k, which is for the key, v the value, then at new node, like this, right? So new node equals to new, voilà, this is also another keyword in C++, new node, then key. That means again, by checking if the key doesn't exist, we'll create a new node and link it at the head. So new node, this v for the key, for the value, then let's say key, comma value. Okay, now the new node now going to be the new node addressing, that is index, right, it's going to be buckets in index. Okay, so yes, Okay, now we're going to, after that, we're going to take now the bucket index, right? Buckets index, right? So the bucket index is going to be equal, now going to be equal to the new node, like this. Yes, everything being equal. Now after that, now we're going to increment our element. So element counts plus plus is basically the same like C. Okay, so we need like to print something out to tell the user like we have inserted something at index this, right? So like C out, I can say inserted, I should put something let's put inserted key, right? I can say inserted key, I can put key comma, then I can put the value. That means you're going to say inserted, you're going to put the key, then comma the value. So it will be like kind of in to make it be in the form of an order, right? So value okay, then I can now close now my bracket. So like just okay, we would say inserted key value, and like the parameters are going to be the key, the value, and then I can say now we'll put something like at index, then I put the index line and say at index, then I put the index. You see, it's quite different anyway. And line. Okay, so that's the look at it. So it checks for the updated value, and if is the case, it says now inserted this at index blah blah blah. Yeah, and that's yes. Now we need to check now for the load. In fact, so inserted this like index. After doing that, we need to check if, right, let me say if the table is getting too crowded, right, we need to check that with that load factor function. So if our load factor function, right, if it's greater than our max load factor, we need to check that condition. If it's greater than that, we're going to call the rehash function, or is it the method or what? That is our call logic up here, right? This rehash call logic. So if that means it's going to check if our that means if you insert an element, we'll check if it's already getting full to that certain we put 75, right? So we'll check if it's already more than 75, if it's already like 75% full. If yes, we're going to create now a new like increase the size of the linked list, yeah, something like that. So increase the size. Okay, that being the case, now next we're going to have another methods, right? This one is going to be like the one to search the logic. That means we'll search to pass the value, go back by reference, or this. In fact, let's just implement it. Okay, so should I even comment it? Something like search. Okay. Okay, so we're going to be boolean. No. What should I put? Yes, boolean. Yes. So we're going to be boolean fine. So we're going to call it find, which is going to take parameters comes first of the constant going to be k, which is going to be the key, reference to the value using by key. K is going to reference the word key, comma, then v that's by reference, like you're going to reference value like this. Yes. Okay, now I'm going to say size index, index going to be because we're going to get the index, pass the key there. Okay, so it's index going to pass the key. Now there's a note. Let's put it. So note k, which is going to be our value, v, k for key, v for value, and yeah, pass it going to be our current equals to the bucket index, right? Buckets, yes. Okay, pass by index like this. Okay, okay, now we need to check now our current. So let me say y current, we say if current key, right, equals to the key, current address into the key, right, equals to key, right. We're going to now like create a variable that's going to like pass the value back through by reference. So is that being the case, I was going to say let's create this variable called results. The result is going to be equals to the current value. Yes, so just basically like pass by reference, so we'll pass value back through reference. Okay, so return I'm just playing the turn. Okay, return for yes, true instead of false. Okay, so yes, so if like that, else is going to be okay, return true. Then if that not being the case, I don't know, it should be it's true or false. It should be false, right, if I am not mistaken. Yes, so when you return true, else our current is going to be current pointing to next. Okay, like this. Okay, so if that not being the case, okay, if that being the case, we need to like if the key was not found now, we need to return instead false. Yes, that one was confusing. If the key was not found, then I'll return false. Yes, this is the correct way. Okay, so we're going to need another method. We have already 100 and something lines. Okay, the next method is going to be like to delete, right? If I've already say inserted search, then what if you want to delete now something from this, right? So I'm going to create another method for delete. So delete logic is simply going to be like the standard linked list not remover, right? So we're going to be a bool, we're going to just call it remove this. Okay, cons k, which is going to be referencing to key, because they're going to take one value key like this. Okay, after that, now we are going to get the size. We are going to name the size. We are going to name our index. Our index is going to be equals to the get index. I'm going to pass a value for key value, right? Oh my god, I'm with that. So it's 12 o'clock a.m. here. Okay, so note key, k, which is for the key, comma, then v, which is for the value, then we're going to do it to current, and current is going to be equals to our buckets, right? Buckets are seen like those rooms in the linked list. Bucket index. Okay, now it's going to be node k for value, v, k for key, v for value. Then let's create a previous. So previous is going to be null pointer. Okay, now we are going to use a while statement here to check, like to further check if it's the first node in the chain, right? So let's say file while current, right? While current will do which is an if statement. If the first thing we do is current in, so if current key, yes, is equals to the key, equals to key, right? What we are going to do now, we are going to this way. Now I'm going to check if it's the first node, right? If it's in the first node in the chain, right? So now if statement brief to check if it's in the first node of the chain. Previous equals to null pointer, then our buckets index is going to be equals to our current which is being allocated to the next, like this current next. So basically this just check if it's in the first node in the chain, yes. Else I'm going to say so let's just do that. I'm going to say since it's already just going to be last one, right, as previous, right? Previous next is going to be equals to current next, like this. Okay, so here this one is just going to like bypass the current node. Okay, well now we have to like manually free the memory, like this is very important. So we use delete current. Okay, element count. If I'm using element, I thought this is a typing error, right? I need to go through all those places where I use the step element, because this will be like an error further as we go along. But anyway, there's no problem. We are going to compare and run. We are going to fix that element count. In fact, since I made that mistake, let me just put or element counts, because just to avoid some kind of mistakes later on. Okay, so we delete element count to decrement it. Yes, so basically we're just going to decrement after we free the memory, we decrement the element count. Now let's like print something out in the screen to tell the user that maybe this particular key has been deleted. So see out, I'm going to say deleted key, let's say key C++. This thing is listed. Deleted key from index, then after I put now the index. C++ syntax is kind of funny. Like, yes, okay, return true. Alright, so when you manually delete, like manually free the memory, right, which is like very fast, then you're going to print out in the screen that deleted key this from index. That, yes, okay. After that, we're going to take our previous, going to be equals to our current. Now our current is now going to be equals to the current next. This, okay. Now after that, we need to, what if now like the key is not found? Now we can say print an statement out saying key not found, something like that. Key not found /n. Okay, let's move. Then put go. Okay, so yeah, that's basically it. And if you like, because that one is like first of all, free the memory, if you want to delete a key, right, that is not found in the linked list or in the note, right, that message should print out that key not found, else we are going to return false. Return. I just have to make sure everything, I knew that. So return is not with U, is return with R, with E. So just some basic typo that I'm making. I'm not supposed to change color. I've been making this typo since putting return as I was spelling it incorrectly. Okay. Yes. I hope I have rectified all the returns. And that one for count, like that element count, maybe I have to correct it later on. But anyway, let's just continue. Return. Okay. It is that I fix all the return values. Yes, this one also return. Okay. So I'm going to return false here. Okay. Now we're going to do another method. This one is going to be like for the start, right? Let me find let me see if the one that will find the longest collision chain from the performance analysis, right? Okay. Oh, this video is getting too long. Okay, so I'm going to say int get longest changes. The name is cool, right? Get longest change. Sorry, this has the longest change, right? So longest chain in int that max. I'm gonna call max len equals to 0. There is a for loop for auto head, for auto head pockets, right? Using int len equals to 0. Now note, right, pass again our key, our value, so that current equals to head, right? Yes, head. Let's say while check the current, while current, okay, while current len plus so increment the len, like we say current now going to be equals to, so basically this is like just to find the longest collision chain from the performance analysis. Okay, just to get increase like the collision chain for performance analysis. Okay, so current current is going to now equals to, after we increment, what is the current? Going to be current next, yes, and this will go. Now our max length now is going to be equals to max vala. You know, remember why we use max? I tell you that max, I'm going to use this max. This max is coming from this library here, algorithm. If not, we cannot use it, so we need to include it in order to use the max. So max, so we're going to be like max length, right? So we're going to take the max len and then for that now we return our max len. Okay. Now for us to like, I think this is our last, if not the last, almost like second to last, our last procedure or method, which is now to visualize what we have done. So, and to see, I'm going to create another method called display. This one will display what we have done. Okay, so I'm going to be just for good formatting, see out, display something on the screen, like maybe a header or a title, something cool. So /n, again it's in quotes like this, /n, right? I can say something just to make something cool on the screen. I can say hash table state, right? Hash table state, something like that. Okay, then and last, next line for good formatting. Okay, now we're going to use a for loops to print that out. So for size, maybe it as I, starting from 0, right? I less than pocket count, right? I plus. Okay. After incrementing, we're going to now like starting from 0 to bucket count, right? We are going to first of all print this on the screen. Okay, so I'm going to say see out. First of all, to make for good formatting. Okay, for good formatting, I'm going to print I. Then now this, so print I. That's just basically okay. Then note, and note now we're going to take our key, which is k, comma our v, which is our value, and going to be current, and this right current equals to buckets. Yes, bucket. Then now we'll pass it the index. That's like the index where it is found. Okay, so like this, why our current, right? Our current will print out something out, right? So this is for loop, if I'm not missing the indices. So this while current, okay, should be like this. So while current will see out, we'll print this on the screen just for boot formatting, right? So while current we'll say print the bracket, like we'll give the key and then the value of the current. Okay, so after that just say, I think I was supposed to separate this video into short parts. It's like it's getting too long, but anyway, just play it in 2x speed if you are watching on YouTube, so that will be faster. Okay, so current current, then pass it by value key, right? Yes, so here we'll print the current key, right? And yes, current, like this, the current key and the current value. Okay, like this. Yeah. No, and that's in the color. Okay, then current. Our current is going to now be equals to current, which is now the next one in the list. Next pages. So other than now, see out null if it's empty. Null, right? So indicate that it's empty. Like this. Okay. After now, we need to print our let me say our load factor and maybe our longest chain. See out. Let's see. Load factor. Let's print the load factor. So load factor will bring the load factor just as an end our line here. Then next we'll clean the longest chain. So longest chain. Yes. End line. Then our semicolon. Okay. Now last, I think yes, our last, this is going to be, wow, I've written a lot of code so far. I think there's going to be a lot of errors to compile to. But anyways, let's continue. I think the last procedure or the last method, I keep on saying procedure because in C we just call it procedures or functions. So the last method is going to be, we're going to create a destructor that would like to clean up all dynamic memory to prevent leaks, right? To prevent memory leaks. And I think yes, we use the tilde sign, right? When you create a constructor, you don't use the tilde sign. When you create a destructor, you create a tilde sign. So we're going to use for our hash table, the destructor for our hash table to clean up the dynamic memory. Okay, destructor hash table. So I'm going to look through it. So for auto head, right, bucket, and 0 y head, we're going to be our note, our key, then V for our values, then we're going to call them, it's going to equal to head. Okay, and that's no color. Our head now is going to be equal to head, which is going to be addressing to our next. Okay, and then we delete now. Right there to free the memory. Okay. Oh, wow. I think that's all. So end the semicolon. I've showed this ends here. I just want to make sure that all the curly braces are at the right position. So this chop note, this hash table, this one, just to make sure that each this thing curly braces is close into its own, to avoid some errors when we're moving on ahead. Okay, yeah, that should be correct. Now I think the last thing we have to do now is our main function now to call everything and print and test our program whether it works. Yes, so that's where 90 something lines of code. Okay, this is where our main function comes in now. Let me just comment it out. Let me see. Functional. Okay. So in our main function now, just create int main, just the same as C. So in int main now, we need to first of all a variable to initialize. So size initialize. How should I put it? Yeah, like our initial size, right? Because our user needs to enter the size of the hash table, right? We need to take it from our user. I want to name it in form like camel case name method instead of lowercase is good. So initial size, okay. Let's see out. Good to ask our user first of all to enter that. I'm going to say enter initial hash table size, something like that. Enter initial hash table size, something like that. Plus semicolon. Now if this the size enter that, so if since is see like if the size enter that is initial size, what's it called? Okay, so if that so like if our initial size not equals to the initial size, like the what we enter is not equals to the initial size, like we need to give, like let me say, a default initial size of like 11. Like remember we gave a default initial size of 11, so we check if the initial size not equals to like the size that entered by the user, right? Initial size, I'm going to say c in clear, call the clear function, or c in dot ignore. Maximum, let me say maximum should be like 1000. Yes, 1000 is supposed to be like, or should I put 10,000? Yes, doesn't really matter. Then slash n for next line. Okay, now we gonna give an initial size of equals to 11 if that doesn't abide. Okay, so next now we'll just have to say create a table where the key, because the key will be an integer and the value will be like a string. So to create a table, remember we did already our hash table. So hash table, we're going to be in to pass any value as an integer string. Then hash table, h2 will be like hash table, then set initial size, right? Okay, so after that now I'm going to say int, or just put some space. Okay, int choice, like we need to create like some kind of options for the user to choose. Is how to spell choice also. In choice key, declare this variables choice key. Okay, then string is going to be an integer. For strings in this is not in caps, right? I hope I'm not making a mistake. So just like this string, because I'm not having give it a highlightation to a highlight value. Okay, so after that we're going to go now through like a while loop to iterate the choice from the user, right? So I'm going to say while true, which is also going to be true, of course. Let's just see out. Next line, I'll open something like the first option. Option 1 is going to be insert, right? Insert an element. option 2 will be like to search first after inserting and search. Then option 3 will be to delete, right? Okay. And option 4 to display. Yes. For display. Okay. And we are now option 5, which is the last one now, to exit. So if you want to exit, then /n for next line. Okay, semicolon. Okay, see out now. Let the user choose their, give their choice, right? Let's say choice. Okay, now for the choice, we need to use now if statement. If choice this, if choice that. But first let's handle the choice for exit. So if the user input choice is 5, right? So if choice goes to 5, what should we do? Well, we should just break. So if the choice is just 5, let's just break. Since it just exists, it will just exit from the decision, right? So let's break. Now use now switch the first check our choice. So switch choice. Case 1. This just like C, right? Case 1, because this is how we handle choice in C. So C plus 1 and C are similar. So in case 1, that means the user wants to insert an element. I'm going to say C out, something like enter the key, right? Enter key. This is going to be an integer to specify. Okay. In each, yes. C in, for just to enter, give it a key. Okay. If you want, now after entering the key, we need to enter a string line or the value. So let's enter value. Right, this value is going to be a string. The string now can now say C. Let's put all of that in one line. C in value. Okay, now that's to insert, right? We call that like ht, which is hash table dot insert. Remember insert function, right? We want to take key, comma, then the value. Okay, now after that we break. That's for case 1. Now case 2, the user wants to search. So for case 2, see out can use the enter key, the key of what you want to search, right? So enter key, all of that will be in one line. C in. So C in we're going to be now get the key, right? The key that you enter. Now to search for value, we need first of all get this if statement. So if first of all the hash table dot find, you will want to find. So if we check and we search through it, so you can say hash table find, passing the value, our key, comma, our value, the parameters. Now we need to check whether it is there first and search through it using that our find. method that we did above. So find C out. Found value. Yes, just going to do that and print the value. Yes, and print the value. Okay. Else. So just to make everything simple. Else. Instead of just putting down everything to be in one line just to maximize space, because we have written a lot of code so far. So else I'm going to put it in one line. Else not found, not like this, not found. Yes, let's search in for next line. Okay. Now break our statement. If the user enters now case 3, right? Case 3. If they want to delete an element, so case 3, we see C out to print something. We say the element want to delete, first one enter their key. Enter. Enter. Okay, so enter spell like that. Enter key to delete. Right. So when the user enters that key, into first C into get the key. Key. And call hash table dot remove. Remember I remove method, right? In the pass the value key. Okay, let's break now statement. The last one is to case 4, right? Case 4. Let's test our program and see whether the logic works and start debugging. So case 4 HTML.display. That means we want to display what we have done so far, or the hash table. So display the hash table, break. Now the default, just like a C. This one, C out, invalid option, something like that, because if what the enter is not in the list, we need to bring some sort of information to tell the invalid option. Yes. So nice. Search in for next line. Okay. If I'm not mistaken, that should be it. And return 0. Always return 0. 0. Okay. Hope there are no mistakes. Let me compile around a bit. I've saved already. Let me go inside our hash form. Okay, let's compile around. I'm going to use the G++ compiler. G++, then hash form dash hold, then the name of our, I'm going to call it this. Wow. A lot of errors as usual. Okay, let's take our time and debug it. Wow. So first of all, this return that we talked about. So like first of all, we have line 90. time to debug. Line 190 was 190. Well, I think this extra, this is not supposed to be there, like seriously. Let's see it again. Clear my screen, compile and run again. Okay, at least the error should reduce. Okay, now that return now line 28, we were spelling return wrongly. Where's line 28? Allah. Return here. It's supposed to be written like this. Okay, line 30 again, return like this. Line 53, right? Let's say vector new bucket. This, let's see, line 53. Line 53 is under is that place for call logic, right? Okay, let me see. Now we have it as, we have vector node. Okay, let me look through into it. 53, okay, vector node v new buckets node bucket pointer. We have to verify that. Let's take what time to verify. Okay, call logic and okay. So line 53, after rehashing trigger, we have vector node k, which is the key, v, which is the value, new buckets, yes, then new bucket count, yes, null ptr. What should be the problem? Let's say okay, by using that, let me see, template argument 1 is invalid. Rehash. Now there's a problem here. Void rehash. Template this way. This is 60. Let me see 60. Line 60, we have size new index SCD key rehash, right? Why? Wow, this video has taken too long, and I'm super tired with all of these errors to correct. But anyway, just showing the reality of what we go through in programming. Take my time and fix it. It's going to be fixed. Okay, we have 60, line 60, which is about size new index. Okay. Hash key. Size t, d this. After for auto, new index is std, this is hash key, this current key modulo new bucket counts. And what's the problem here? The same size concave on this. And current count. Wow. Max layer, this there are a lot of errors so far. Let me see. Not declared in the scope. Max layer not declared, like seriously. Let me see. 160, 161. Little max line. Ah, ints. This was int here, max length. But again, let me just compile that again. At least the error should reduce. This one is now this one for size index. The new index, current new nodes. Wow. You know what? Let me just pause the video, do some corrections, then I'll come back. Say to add something. Okay. In fact, there are a lot of errors here. Let's take our time. Sorry. We first all have, should I start from the bottom or from the top? I think I should start from the top. Okay, let's all have line 53. It says template argument 2 is invalid. This function has has is not a member of std. Do you mean hash? Let me see 53. Or is it 60? Okay, this hash here. Then now for 52. 53 is in member function void hash table rehash void hash table. Hash table is inside let's see, template argument 1 is invalid. Vector node this these are also complain about my closing. So we have vector nodes, vector, the node, the key, the value, star to new buckets, right? New buckets, the new bucket count, then null btr. What could now be the problem? Let's see. What's the next error? It's a expected primary expression before this token. Line 60. Page 60. Okay. Let me expand the screen. It's taking time, but we'll resolve it. Okay, 53. They say template argument 1 is invalid. It's like I'm not using the template, or how? Wow. Okay. 62. See, I need to mention 62. Current 62 says the human buckets new bucket was not defined. New buckets is like I did not define new bucket, or how? I think I defined new bucket, right? Let me see. Size new buckets 2. And this is a new bucket with S. But when I was doing this, I was putting its half size new bucket count, and the other one new buckets. Where did I define those new buckets? I'm tired. Okay. Then now we have let's say new node was not declared in this scope. Did you mean next node? 65. Okay, was next node 65 was next node. What again? 62. They said the human buckets new buckets was not defined. 62 we have current bucket, right? Equals to is another auto for auto buckets, and size new index current next new buckets equals to new index new buckets new index equals to current and current next node. Yes. Now my problem is I think that one is resolved. 69, they say a new bucket was not declared. Did you mean bucket? Did you new buckets? This new bucket, did I not really define new buckets? You kind of maybe it's true. New buckets. Check it, okay. But I searched that vector node new buckets. If you want your new bucket count this. Mm-hmm. 69 buckets equals to move new buckets. And I say no new buckets was not found. Bucket count is this is the error. New buckets was not declared in this scope. Did you mean buckets? In member function bool hash find count hash result was not declared in this scope. Result that was 60 hash constant result h109 line 109 we have result 116. Result was not declared after we are doing the search. Let's see. We have returned true result, console result v comma, but here we said bool count v for value. This was results. Okay, result. Okay, I just solve them one by one. In member function bool this constant pre was not declared 130 something 132 hash was preview with v. These are errors you have to correct when you have the coding. Then lines 52, let's say head has not been declared. 52 152 152 HE error HE has not been declared for auto head buckets. So we have like key not found, head was not declared. How? Let me see. Auto heads, head buckets. According to here, it is not really complete. C++. 152. What the heck? She has not been declared right. For the head 7. Auslan head this current blah 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 and oh. Next line is expected semicolon before token 152. This is 152. It should be like this. Okay. Let me compare one again. This was safe. Oh, the errors are reducing one by one. Oof. Anyway, that's the life of a programmer. You need to debug. Now we have 959. 69 first. In 969, it says new bucket was not declared in this scope. Did you mean buckets? 69 new buckets, new buckets. That's where we had our core logic, right? And they say it was not declared in this scope. Okay, in that we have buckets equals to move new buckets, and it was not declared. Let me just start from the beginning. Okay, we have core, refresh, rehash, we have size. This new bucket, right? New bucket count, next prime bucket count by 2. We have see our refreshes, new bucket count, then vector notes. We give it the key, the value, the new buckets inside. There's a new bucket count, is no pattern. Then for head buckets node current head y current. We have node the next node because we got a next size inline new bucket count current next new buckets index new bucket index current next what. But from all indication, new buckets is here. New bucket was declared here, if I'm not mistaken. And this, they have the same error, the same hashing in member function void hash. The hash function distance is 53. Template 1 is invalid. New bucket count no 1. All wait, that's line 53, right? This video is taking too long. Okay, new bucket count node. What's the problem here? Okay, let's go through again. So we have rehash, void rehash, this, we have size, new bucket count, if they are not mistaken. Then next because new prime bucket count times 2. See how refresh this, see out Rehashing triggered. We have new bucket count, buckets vector, which is 53 now, and it's a problem. We have vector note k v this. It's like I've seen the error. So like this. So we have our vector which takes in the node kv, and all of this is still inside. So we forgot to put inside this quote greater than or equal to sign. So it's inside the parameters vector here and here. Anyway, let's see if I'm correct. This video took so much time. Let me clear my screen. And it ran. Wow, debugging this kind of code can be stressful. 100, 200 something like that. Anyway, let's test our we're going to test our this thing, our program, and to have like all the functionalities to see whether it really works with all the functionality. Let me just increase the screen this way. So I'm just run the program. This one on the screen. That's the compile version. So version dot /hash function. Okay, enter the size. So to test all the properties, I think we should first start with the collision test, right? To prove that two different keys can live in the same bucket or in the same linked list or the same list, right, or array, or without overwriting each other. So if I initialize my, let me say I give a size of like 11. Oh, controls, what just happened? Let me rerun it again. It's like this a problem. I give myself 11, press enter. There's a key that is pressing. This is weird, right? I don't know, there's a key that is pressing automatic. But if I enter, let me run again. If I enter a size of 3, it is running without ending. This is weird. There's a problem somewhere. Showing maybe in the looping. Okay, when I enter a size, let's see how I enter initial size table. Left hand side 2. Wow, this is strange. Enter a choice, it just keeps running. It should be a loop problem somewhere here. I think we have to recompile and run again because I don't know why the program is like behaving as such. Let's recompile and run again. Kind of crazy. Let's recompile again. So if I want to enter, like, test our first condition to test something like the collision, if elements, like, to prove that two different keys can live in the same bucket without overwriting each other. So if I enter something like 11, voila. I don't know whether it was like my key stroke pressing. Oh, that's changed. Anyway, I'm going to provide this code on GitHub. You can check it. So if I enter 11, let me see, as my size, then I insert, let me see how to insert, I put 1. So if I want to insert a value, my first value is 11, my size was 11, right? If I input a value, if I give an integer, a key of 11, then maybe a string of, select called dct, and say dct, right? Okay, they say inserted 11, then this is then the key, then the string, like the value at index 0. So if I input another value, like, let me say I want to input another value, and I put again 11, you know that will be in the same index, right? So in this case, now I'll enter, let me say Vela. Okay, and let me run a display function to display. Well, I see now it's it shows instead of, so like it shows what am I doing? We have Vela and there is no dct. This is strange. Wow, this code is interesting. Normally at index 0 we are supposed to have like my name, then next one should be like natural dct, then Vela. This is strange, this is strange, this is strange. Wow, because you say we first have inserted this and this updated key. Oh yeah. So this was now the updated function, like it updated, well, instead of deleting or instead of how can I say, it like kind of updated, you say updated key at index 0, so it changed it to be from dct to Vela. But that's not the function I want to test. I want to test something like, I don't know where I get my point. Let me just let me exit it and run again. This program is way off my hands. So let me say 2, I give a size of 2, then I want to insert 1. So the key, I give a key of let me see So if I give a key of 7 or of 1, yes, then a string of dct, yes, I input again 1, I give it a key of 1 again, and I enter my string as Vela. It updates. Normally I was supposed to, like, when there's a collision, instead of just updating, it should like make in a form of a string, like make a list. Wow, this is very creative, more than I thought. Again, I'm spending a lot of time. Let me see, this is already how many hours? 2 hours. But anyway, I think I'm going to make a part 2 of this video, so that we'll resolve all of this issue because of time. But let's see other stuff, like let's test other functionality whether it works. Like, let me say to showcase deletion of a list. So after inserting 1, let me display. Okay, Vela. Now if I want to delete Vela, I can say enter 3. The key was 1, delete 1 from list, so if I play 5, so it's no more there. Okay, let me exit and run again, and maybe why should I test again? Let me run again. In fact, I'm still wondering why this is working this way. It's running, but it's not like I wanted. If I enter a size of, let me see, 11, I insert, let me see, I give a value like, how can I say, add index 0, I'll give a key 22, then my name, I give it dct, then I insert again, I give it a key 11, I enter the name Vela. Wow, it worked. Wait a bit, let me display it. Number 4. Yes, it worked. I was making a mistake. I was trying to think, I was thinking as if when I was entering, like entering the key was actually doing this modulo division. So when you take 22 modulo 11, which is the size, right, it's going to return 0. When you take, that means the remainder is going to be 0 now, so that will be index 0. When you take 11, it will be 11 divided by 11, and the remainder is 0. So I inputted 2 values or 2 strings in the same key, which is in this index 0. And you see that instead of it creating a collision, it left from, it first of all put the key 11 with the string Vela. Then after I entered another string which was in the same index. Instead of creating a collision, it expanded. It created a linked list from here to here. I hope you get the point. So we gave now, the second one was the value 22, and the name was dct. So you see how it's like. In fact, let me add another value, like what again? What are factors of 11? We have 11, we have 22. If I add another 11, I'll say 33, right? If I'm not mistaken, this. Let me start. Let me put 1, and I enter a key of 33, and I enter a value of let me say subscribe. I don't know how to display subscribe at index 0. Okay, so display. I see what is happening, right? So it just keep on adding the list. Wow, the program works. So basically that's it. And we could delete from the list, we could search. So let's try and search a bit too. And the value I want to search, let me try to search. Density was 22, so 22. So it say found value density. So density is in the list. So let's search for something that doesn't exist. And let me say like one doesn't exist. So it says not found. And we could also equally delete. Let me say let's delete Vela. So let's put the D for delete, and the value to delete was 22, right? Deleted key 22. Now let's input 4 to verify. You see that 22 was insert density. Yes, 22 was density. So we deleted 22 and left Vela and subscribe. Wow. Okay. Wow. This is interesting. Now the load factor, it shows that the linked list is full. 18% of it is being used. Then the longest chain is 2, as you can see. 1, 2. Let's insert maybe something at index. No. Anyway, but you get the point that the video is too long and all the functionalities work. It handles all the conditions like from the debugging, the coding. In fact, it just shows the video is too long, but the link is going to be of the source code going to be provided in below. You can check it in my GitHub repository. So yeah, that was it. Let me enter 5 to exit. Yes. Wow, I'm still kind of like surprised. This video was too long. Thank you very much for watching. What can I say? Yes, like it was amazing, and I really thank you guys. So if I'm to say something, I'll just say let me say, here's a takeaway, right? Hash tables are powerful, but only when designed correctly. So if you ignore lot factor, ignore collision, or use bad hash function, your system will silently become slow. And yes, again, it was a very long video. I think I'm going to stop from here. It's 2 hours 20 something minutes. So yeah.